Hi, so this is a lecture on probability and statistics in which we are discussing binomial distribution. This is second unit of probability and statistics. So we start our discussion on discrete uniform distribution. Discrete uniform distribution. A random variable x capital X has a discrete uniform distribution if and only if it has or its probability distribution is given by probability of x that is equal to 1 upon n for x is equal to x1, x2, x3, and so on, etc. The random variable x variable capital X is then called discrete uniform random variable. For example, the distribution if we take this is x is equal to 0, x is equal to 1, and probability of x that is equal to 1 by 2 and 1 by 2, because we have two values x1 and x2. x1 is 1, x1 is 0 and x2 is 1, and the probability of x1 that is 1 upon 2 and probability of x2 is also 1 upon 2. That is probability of 0 is 1 upon 2 and probability of 1 is also 1 upon 2. Such type of distribution is called discrete uniform distribution. And if we have another x is 0, 1, 2, 3, and probability of x that is 1 by 4, 1 by 4, 1 by 4, 1 by 4. So this is also, these are discrete uniform distribution. So now next is Bernoullis distribution. A random variable x, random variable capital X, which takes two values, takes two values 0 and 1 with probability probability Q and P, Q and P respectively. That is probability of x equal to 0, then we get Q, and probability of x is equal to 1, we get P. Right? And we know that P plus Q equal to 1. So this implies Q is equal to 1 minus P. So if we know the probability of failure, then we can find the probability of success. So Q is equal to 1 upon P is called the Bernoulli's discrete random variable is called a, this is called a Bernoulli's discrete random variable, and is said to be or said to have the Bernoullis distribution where P and Q takes the probability of success, and failure respectively. So P is a probability of success and Q is a probability of failure. Then the probability function of Bernoulli distribution can be written as probability of x equal to x, that is equal to P की power x into Q की power 1 minus x, where x takes value 0 and 1, and it is 0 otherwise. So it was discovered by the Swiss mathematician James Bernoulli. So what are the characteristics of Bernoulli's distribution? That is, the characteristics are number of trials is only 1. Right? Second, constant of the distributions, constants of the distribution, and third one is its mean. Even the second one is we have Q equal to 1 minus P, and third is constant of distribution, and fourth is we have its mean, that is expectation of x is equal to P variance, that is variance equal to expectation of x square minus expectation of x whole square, that is equal to PQ, and standard deviation, that is under root of variance, that is under root of PQ. So these are. So examples of Bernoulli's trials are examples of Bernoulli's trials are we toss a coin, we get head or tail, right? Head or tail. Second, we throw a dice, we get even number or odd number. Performance of a student, performance of a student in an examination. Whether it is pass or fail. So how we can find the mean of the Bernoulli's discrete random variable? So mean of the Bernoulli's discrete random variable x. Discrete random variable x. That is, we have two values x equal to 0, x is equal to x. We have x equal to 0 or x equal to 1. And what are the probabilities? When x equal to 0, we have probability q, and when x equal to 1, we have probability of success, that is p. So now we know that we denote mean by mu, and it is expectation of x, that is equal to summation, because it is a discrete random variable. So we take x equal to 0, comma 1. We have only two values, and xi into probability of x equal to xi. So when we put x equal to 0 into probability of x equal to 0 plus 1 into probability of x is equal to 1. 0 into q plus 1 into p, that is equal to p. So mean of Bernoulli's distribution, that is equal to p, right? So expectation of x, that is mu, or we can say mean, is equal to. So in case of Bernoulli's distribution, mean is equal to. Now variance. How we can find variance? Variance of x. That is, we denote this by sigma square. And sigma square is equal to expectation of x square minus expectation of x whole square. And that is equal to summation x is equal to 0. Even we can take here also, we can take I equal to 0. X1 and x1 is, this is our x1. We can say this is our x1, even x0, and this is our x1. Okay. So x is equal to 0, comma 1, x square into probability of x equal to x, minus, we have already calculated that expectation of x, that is p square, p into expectation of x is p, so square of expectation of x, that is p square. So now when we put x equal to 0, so 0 into 0 square into probability of x equal to 0 plus 1 square into probability of x equal to 1 minus p square. So we get 0 plus it is p minus p square. So p, we can take p to be common, so 1 minus p, and we know that 1 minus p is q, so it is p into q. So variance is pq. So variance of x, that is sigma square, so it is pq. Now standard deviation, that is equal to under root of variance of x, that is under root of pq. So this is how we can define mean, variance, and standard deviation for Bernoullis distribution. Next is binomial distribution. Binomial distribution. A random variable x, a random variable capital X is said to follow binomial distribution if its probability mass function, if its probability mass function is given by probability of x is equal to x, that is equal to, we also denote this by px, and that is, or even we can denote this by fx, f of x, that is equal to ncx p की power x q की power n minus x. Here x takes the value 0, 1, 2 up to n, and 0 otherwise. And again, p is probability of success and q is probability of failure. So we can take q to be q is equal to 1 minus p. Here q is equal to 1 minus p, or we can say p plus q equal to 1. So examples of distributions, binomial distribution: the number of defective bulbs in a box containing n bulbs, the number of computers lying idle in an IT department having n computers, the number of PhD in a group of n men. Now, what are the conditions for binomial distribution? The number of trials n is finite. The trials are independent of each other. The probability of success P is constant for each trial. Each trial must result in a success or a failure. So the examples: so let us discuss one example. A fair coin is tossed 6 times. Find the probability, find the probability of getting 4 heads. So coin is tossed 6 times. Right? A fair coin is tossed 6 times. We have to find the probability of getting 4 heads. Now let P be the probability of getting a head. Of getting a head. And Q with the probability of getting a tail. Tail means not head. Right? Then P is equal to 1 upon 2. If we toss a coin, that is the probability of getting head. That is 1 upon 2. And Q is also equal to 1 upon 2. That is 1 minus P. So 1 minus 1 by 2 is again 1 by 2. So we get P and Q. Now how many times we toss the coin? 6 times. So number of trials n equal to 6. So given n equal to 6. We know that probability of getting 4 heads while tossing the coin 6 times is given by probability of x is equal to 4, because number of trials n are finite, right? That is 6. Number of trials are 6. That is finite. So we can use the binomial distribution. So probability of x equal to 4. 4 is the probability of success. We get 4 heads. So that is, we have number of trials n equal to 6. So 6c4 ncx. So we use ncx e की power x q की power n minus x. So ncx means 6c4 p. What is p? We get 1 upon 2 power 4 into, again q is 1 by 2. So we get 1 by 2 to power 6 minus 4. And 6 c4 means 6 factorial divided by 4 factorial into 6 minus 4, that is 2 factorial, into 1 upon 2 की power 4 into 1 by 2 की power 2. So that is 6 into 5 upon 2 into 1 upon 2 की power 6. And that is equal to 15 by 24, 64. And after calculating, we get 0.2344. So this is the probability when we toss a coin 6 times, and we get 4 heads. Example 2, 10 coins are thrown simultaneously. Find the probability of getting first part is at least 7 heads, second at least 6 heads, third at most 6 heads. So P with the, again we have coins, right? Number of coins are thrown, that is 10 coins are thrown. So it is, number are finite, so we can use binomial distribution. So P with the probability of, let P probability of getting head. Probability of getting head while tossing 1 coin, that is 1 upon 2. Q probability of not getting head. Not getting head means probability of getting tail. That is again 1 upon 2. K equal to 1 minus 2. Now given that n equal to 10, given n equal to 10, the probability of getting x heads, the probability of getting x heads in a throw of 10 coins is probability of x equal to x, 10cx, if we have x heads, right? So 10cx into 1 by 2 to power x into 1 by 2 to power 10 minus x. Here we have x equal to 0, 1, 2, 3, up to 10. Now, in first part, what we have to show, probability of getting at least 7 heads. That is probability of x is greater than equal to 7. And probability of x is greater than equal to 7 means that is probability of x is equal to 7, or probability of x is equal to 8, or probability of x is equal to 9, or probability of x is equal to 10. Either we get 7 heads, 8 heads, 9 heads, or 10 heads, because all are independent, so we can add them. So what is the probability of x equal to 7? So it's 10c7, 1 by 2 की power 7 into 1 by 2 की power 10 minus 7, that is 3. Probability of x equal to 8, 10c8, 1 by 2 की power 8 into 1 by 2 की power 2. Probability of x equal to 9, 10c9, 1 by 2 की power 9, 1 by 2 की power 1. Probability of x equal to 10, 10c10, 1 by 2 की power 10, 1 by 2 की power 10 minus 10 is 0. So after solving this, when we solve this, we get 176 by 1224, and that is 0.1719. So this is the probability of at least 7 heads. What is the second part? We have to find probability of at least 6 heads. At least 6 heads means probability of x is greater than equal to 6. So we can write this as probability of x is greater than equal to 6 means x is equal to 6 plus probability of x is greater than equal to 7. We have already calculated 7, 8, 9 and 10. Probability of x equal to 7. So 6 plus greater than equal to 7. So we can find probability of x is greater than x equal to 6, 10c6, 1 by 2 to power 6 into 1 by 2 to power 6, 10 minus 6 is 4, plus we have already calculated this 176 upon 1024. And again calculating the value of this, we get 386 over 1024, that is 0.3769. The third part is we have to calculate probability of at most 6. Probability of at most 6 heads. That is either we get 6 or less than equal to 6. And we know that probability of x is less than equal to 6 means 1 minus probability of x is greater than 6. And x is greater than 6 means probability of x is greater than equal to 7. X is greater than 6 means 7, 8, 9, 10. So it means that is probability of x is greater than equal to 7. And x is greater than equal to 7, we have already calculated. This is 176 over 1024. And after solving, we get 848 over 1024, that is 53 volt over 60. So in this way we can solve examples related to. So we will discuss more examples and how we calculate mean, variance, standard deviation, and even movement generating function in the next video. Thank you. Have a nice day.